Number 1, the crowned eagle. In 1924, a limestone quarry worker in Taung, South Africa, handed a small fossilized skull to the anatomist Raymond Dart. The skull belonged to a child, an Australopithecus africanus, roughly 3 years old, dead for approximately 2 million years. Dart recognized it as one of the most important fossils ever found. But for 8 decades, nobody looked closely enough at the damage. The eye sockets had puncture marks. Deep gouges scored the bone around the orbits and across the top of the skull. For most of the 20th century, researchers assumed a ground predator had killed the child. A leopard, maybe. A hyena. Then, in 2006, the paleoanthropologist Lee Berger picked up the fossil's face and nearly dropped it. He later described the moment as a shock. After 80 years, the evidence had been hiding in plain sight. The pattern of damage did not match any terrestrial predator. It matched an eagle. Berger's team compared the Taung Child skull to over 600 bones collected beneath crowned eagle nests in the Thai rainforest of Ivory Coast. The match was precise. Scratch marks running across the frontal, orbital, temporal, parietal, and occipital regions formed a taphonomic signature now recognized as uniquely diagnostic of raptor predation. Crowned eagles kill primates by striking from behind, driving talons into the skull. They carry the head to the nest. The brain and eyes are consumed first, sometimes with the help of hungry chicks. The crowned eagle is Africa's most powerful eagle relative to prey body size. It routinely kills ungulates weighing up to 30 kilograms. Its talons are disproportionately large, and its legs are strong enough to simply crush a primate's skull on impact. The Taung Child weighed an estimated 12 kilograms, 26 pounds, squarely within the normal prey range for crowned eagles hunting monkeys. This is not an ancient problem that vanished. There's a credible report of a 7-year-old boy, roughly 20 kilograms, ambushed by a crowned eagle that drove talons through his throat and chest. In the 1970s, the raptor biologist Simon Tomset investigated an alleged kill of a 4-year-old girl in Kenya. A severed limb was found cached in a tree by an eagle. A child's skull was recovered from inside a crowned eagle nest in South Africa. In 2019, in Ethiopia, a martial eagle killed a child and wounded at least 2 more before a teenager killed it with a cane. Modern crowned eagles still primarily hunt primates. Over 90% of their diet is mammals, and monkeys are the preferred prey in many populations. Adult male monkeys are disproportionately represented in the diet. They patrol alone, they have loud calls that attract eagle attention, they take aggressive action against eagles, which makes them conspicuous. The eagles do not need to carry whole prey. They dismember carcasses on the ground and ferry pieces back to the nest. Vervet monkeys have evolved distinct alarm calls specifically for aerial predators. A different call than the one for snakes. A different call than the one for leopards. That behavioral split suggests millions of years of eagle predation pressure encoded into primate neurology. 3 theories compete to explain the significance. The mainstream view holds that eagles were opportunistic predators picking off vulnerable young hominids, one selective pressure among many. Berger proposed a stronger version. He concluded that birds of prey have been one of the most important selective forces in primate evolution for a very long time, and that being hunted by predators may have helped our intellect evolve. Then there is the fringe hypothesis. Some researchers propose that aerial predation was the primary driver, forcing hominids out of trees and onto the ground in coordinated groups. That eagles literally pushed us toward bipedalism and social cooperation. The knowledge of eagle predation on hominids was functionally lost for 80 years because researchers assumed the Taung Child was killed by a ground predator. The forensic signature was misread until modern comparative studies corrected the record. Crowned eagles still hunt primates today using the same methods. Our primate relatives still scream the same alarm calls. But eagles were not the only predators hunting from an unexpected angle. Something far larger was waiting at the one place every hominid had to visit. Number 2, Crocodylus anthropophagus. In 2010, a team led by Christopher Brochu, Jackson Nero, Robert Blumenschein, and Larry Densmore formally described a new species of crocodile from fossils discovered at Olduvai Gorge, Tanzania. They named it Crocodylus anthropophagus. The species name comes from Greek. It means human eater. Co-author Brochu remarked at the time that he thought people would get the joke. It was not entirely a joke. The animal was estimated at 7 to 7.5 meters in length. That made it the largest predator in the entire Olduvai ecosystem during the early Pleistocene, roughly 1.845 to 1.839 million years ago. Its skull had a deeper snout than any living relative and distinctive bone horns flaring from the back, giving it a profile unlike any modern crocodilian. Before this identification, scientists had assumed the Olduvai crocodile fossils belonged to prehistoric Nile crocodiles. They were wrong. Something entirely different had been lurking there. The type locality for Crocodylus anthropophagus sits near the type localities for both Homo habilis and Paranthropus boisei. This crocodile lived alongside our direct ancestors, and crocodile bite marks had already been found on hominid bones from Olduvai Gorge. This species is the prime suspect. The asymmetry is chilling. Bite marks on small-bodied hominid bones suggest attacks by subadult crocodiles. The larger adults could have consumed entire individuals without leaving any skeletal trace at all. Adults of Homo habilis stood only about a meter tall and weighed approximately 40 kilograms. That is roughly the size of a modern 12-year-old. Against a 7-meter predator, the encounter was not a contest. The Olduvai ecosystem was a savanna lake system where water was scarce. Every animal, including hominids, was funneled to predictable water sources. Early hominids went to freshwater environments to drink, hunt, and scavenge. Crocodiles were always there, waiting at the water's edge. This was an ecological trap. The resource you needed to survive was guarded by something that wanted to eat you. Modern Nile crocodiles still kill hundreds of people annually across Africa. They are smaller than Crocodylus anthropophagus was, and Zhao has described his holy grail as finding a hominid fossil with a crocodile tooth still embedded in it. In 2016, researchers discovered a new partial cranium at Olduvai, nicknamed Black Sun, found during an annular solar eclipse. The mainstream interpretation holds that Crocodylus anthropophagus was an opportunistic ambush predator, behaving much like the modern Nile crocodile, taking hominids when available alongside other prey. The archaeological theory proposes that water edge predation pressure was a major evolutionary driver, forcing hominids to develop cooperative water gathering strategies, tool use for defense, and possibly early projectile weapons. The speculative theory goes further. Some researchers suggest crocodilian predation may have been so intense it influenced hominid migration patterns out of wetland-rich East Africa. That crocodiles literally pushed us toward drier, safer landscapes. As the largest predator in its environment, Crocodylus anthropophagus outmatched contemporary mammalian carnivores like Dinophiles, which weighed between 100 and 200 kilograms. The water's edge was the single most dangerous place in the hominid world. But the land held its own horrors, specifically a creature that was already eating us and then throwing up the evidence. Number 3, Pachycrocuta brevirostris. This was the largest hyena that ever lived. Pachycrocuta brevirostris averaged approximately 110 kilograms, roughly 240 pounds, about 20% larger than a modern spotted hyena. Very large individuals may have reached 150 kilograms. It stood about 90 to 100 centimeters at the shoulder. Its skull dimensions paralleled those of the largest southern African male lions. The animal's teeth tell the story of its lifestyle. The large premolars and a powerfully built mandible show strong adaptation to bone cracking. The fourth premolars and first molars have zigzag hunter Schrieger bands in their enamel, a structural feature indicating extreme adaptation for crushing hard materials. This was a specialist. It ate bones the way we eat bread. The reason Pachycrocuta matters to human history centers on a cave in China and one of the most famous misunderstandings in paleoanthropology. At Zhoukoudian, near Beijing, researchers in the early 20th century found skulls of Homo erectus with their faces smashed in and their brain cases opened. For decades, the accepted interpretation was cannibalism. Peking man had been eating Peking man. The story entered textbooks. It shaped how an entire generation understood our ancestors. It was wrong. Modern taphonomic research concluded that Pachycrocuta was responsible for most of the bone modification at Zhoukoudian. The damage originally attributed to cannibalism was hyena feeding. The postcranial bones show extensive puncture bite marks and fracturing patterns characteristic of hyena damage. The skull fracturing, the biting on the facial region to expose the brain, matched hyena feeding behavior, not human butchery. The most disturbing specimen is femur 5. It shows clear signs of stomach acid etching and regurgitation by hyenids. A hyena ate a human, then it vomited the bones. 67% of the Homo erectus sample from Zhoukudian shows bite marks or other modifications from large carnivores, particularly Pachycrocuta. The cave was primarily a hyena den that hominids occasionally used, not the other way around. The evidence extends beyond China. A skull of Homo erectus georgicus from Dmanisi, Georgia, displays bite marks that may be attributable to Pachycrocuta, suggesting a predator-prey relationship spanning thousands of kilometers. At one mammoth carcass site in Spain, evidence shows consumption by both humans and Pachycrocuta. They were competing for the same dead animals. A newly discovered skull from Jinyuan Cave in Dalian, China, surpasses all previously known specimens in size. It sets a new record for Pachycrocuta body dimensions. Pachycrocuta first appeared during the late Miocene. It went extinct in Europe around 800,000 years ago during a major faunal turnover, and globally disappeared during the Middle Pleistocene, about 400,000 years ago. It may have been outcompeted by spotted hyenas arriving in Europe. The mainstream interpretation calls Pachycrocuta a kleptoparasitic scavenger that consumed already dead hominids found opportunistically. The archaeological theory notes that the stomach acid evidence proves bones went through a hyena's digestive system, but whether this represents active predation or scavenging remains genuinely unclear. The speculative theory argues that 67% is too high for chance encounters. That percentage suggests systematic predation. For generations, we told ourselves a story about ancestral savagery, cannibals cracking each other's skulls. The truth was different. We were being eaten, and the animal responsible was not the only large predator with knife-like teeth stalking our ancestors. The next one had been doing it for millions of years longer than anyone realized. Number 4, Machairodus. The name means knife tooth in Greek. Johann Jakob Kaup named the genus in 1832. The entire subfamily Machairodontini, the saber-toothed cats, takes its name from this animal. And the largest species, Machairodus kabir, was enormous. Estimates place it between 770 and 1,080 pounds, 350 to 490 kilograms. The largest living cat, the Siberian tiger, maxes out at roughly 660 pounds. Machairodus kabir outweighed it by a wide margin. Fossils from Chad reveal 3 different species of saber-toothed cats living in the same region. Researchers described it as a lost paradise for carnivores. This is directly relevant to human origins. Hominids such as Sahelanthropus tichidensis, known as Tumai and recognized as one of the earliest known human ancestors, lived in the same area. They could have been prey for these cats. The canine teeth were long, thin, flattened side to side, but broad front to back, like the blade of a knife. The front and back edges were serrated when first grown, like steak knives. Machairodus was an ambush predator. Its legs were too short for sustained chasing. It was likely a powerful jumper, relying predominantly on neck muscles for the killing bite. The cervical vertebrae show adaptations for vertical striking motions. Fossils of Machairodus affinistus reveal a high percentage of tooth breakages, indicating these were riskier hunters than later saber-toothed cats. Some specimens show survival of severe injuries like broken mandibles. A solitary cat with a broken jaw typically dies. Survival suggests possible social groups providing food to injured members. At the Schöningen site in Germany, researchers found 5 fossil teeth and 1 humerus of Homotherium latidens, alongside 300,000-year-old wooden spears. The humerus shows evidence of hominin impacts. Humans used a saber-toothed cat's arm bone as a hammer tool. The researchers concluded that these cats as carnivore competitors would certainly have impacted the lives of late Middle Pleistocene hominins. The wooden spears found at Schöningen may not have been used only for hunting. They may have served as self-defense against these predators. In 2023, 4 Machairodontine species were identified at Langebaan, South Africa, confirming these cats were far more diverse and widespread than previously thought. The mainstream interpretation holds that Machairodus specialized in large herbivores like horses and rhinoceroses, and hominids were incidental prey. The archaeological theory emphasizes the Schöningen evidence. Saber-tooth remains found with human spears suggest active, dangerous competition that shaped human weapon development. The speculative theory argues that the sheer diversity of saber-toothed cats at sites like Chad and Langebaan means hominids evolved under far more intense feline predation than currently modeled. Possibly the primary selective force driving tool use, saber-toothed predation on hominids stretches back to the very beginning of our lineage, but as hominids moved north into Ice Age Europe, they encountered a different kind of cat, one that wanted the same thing they did. Number 5. The cave lion. Panthera spelaea weighed approximately 300 kilograms, 660 pounds, roughly 25% larger than modern African lions. It ruled Ice Age Europe from roughly 370,000 to 13,000 years ago. The central conflict was territorial. Lions and early humans competed directly for cave shelters. Caves were not neutral ground. They were contested resources. A cave lion skeleton found in Germany had a Neanderthal spear embedded in its ribs. The wound had healed over. The lion survived the attack and lived for months afterward. Neanderthals were actively hunting cave lions with wooden spears, either incredibly brave or incredibly desperate. Fossil evidence from multiple European sites shows lions and humans alternately occupying the same caves across thousands of years. An alternating occupation pattern. One season, hyenas. The next, humans. The next, lions. A deadly rotation stretching across millennia. The Chauvet cave paintings in France, approximately 36,000 years old, feature prominent panels of cave lions. Lions appear in cave art more frequently than almost any other predator, deep underground, in hidden chambers, on walls that required crawling through darkness to reach. The Löwenmensch, the Lion Man figurine from Germany, was carved 40,000 years ago from mammoth ivory. It depicts a human-lion hybrid. It is one of the oldest known sculptures in existence. Some researchers read the repetitive lion imagery as evidence of generational trauma, cultural processing of predator fear passed down through artistic tradition. Cave lions likely hunted in coordinated groups. They had superior night vision, silent movement, and explosive speed, hunting primarily at dusk and dawn when humans were most vulnerable. Their range spanned from Britain to eastern Siberia, overlapping with all major human populations across Europe and Asia. Isotope analysis shows they preferred reindeer, horses, and bison. But they hunted whatever was available. Fire was the primary defense, but cave lions could wait out the flames. The mainstream interpretation holds that cave lions were primarily large herbivore hunters that occasionally preyed on humans, with cave competition being incidental. The archaeological theory frames the competition for shelter as one of the most persistent and dangerous conflicts of the Pleistocene, a defining experience of Ice Age human life. The speculative theory proposes that the Löwenmensch figurine and repetitive cave paintings suggest lions held quasi-religious significance. That predator fear was the origin of symbolic thought itself. That art began as a way to process the terror of being hunted. Cave lions went extinct approximately 13,000 years ago. Frozen cave lion cubs preserved in Siberian permafrost have allowed scientists to study actual tissue and fur. But the cave lion was a solitary or small group hunter. The next predator brought something different, intelligence applied across an entire pack. Number 6. Dire wolves. For most of the 20th century, dire wolves were classified as close relatives of gray wolves. In 2021, ancient DNA analysis revealed they were not closely related at all. Dire wolves belong to a completely separate lineage that diverged roughly 5.7 million years ago. They looked like wolves. They lived like wolves. They were not wolves. Dire wolves weighed approximately 68 to 80 kilograms, 150 to 175 pounds. Significantly larger and more robust than modern gray wolves, broader skulls, more robust jaws, larger teeth adapted for crushing bone. Over 4,000 dire wolf specimens have been recovered from the La Brea tar pits in Los Angeles alone, more than any other predator at the site. They hunted in coordinated packs using sophisticated communication. Pack sizes potentially reached 15 to 30 individuals. Their brains were slightly smaller relative to body size compared to gray wolves, but their bite force was significantly stronger. The fossil record shows frequent injuries consistent with tackling large, dangerous prey: broken ribs, punctured skulls, infected wounds. Some specimens show healed injuries suggesting pack members supported injured individuals. Sophisticated social bonds. Wolves and their relatives learn. They learn human behavioral patterns, migration routes, camp locations, water collection schedules. During Ice Age winters, wolf packs would have been the most persistent nighttime threat to small human groups huddled around fires. Fire was the primary defense, but wolves could wait for days, circling camp perimeters, testing for weak spots. Isotope analysis shows dire wolves occupied a slightly different ecological niche than gray wolves, preferring larger prey in more open landscapes. Their geographic range stretched from Canada to South America. They went extinct approximately 13,000 years ago, coinciding with human arrival in the Americas in the end Pleistocene extinction event. The hypothesis is that they could not adapt their hunting strategies when megafauna prey disappeared. Gray wolves shifted to smaller prey. Dire wolves did not. The mainstream interpretation attributes their extinction to megafauna loss combined with competition from gray wolves and humans. The archaeological theory holds that the behavioral intelligence of wolf-type predators was so significant a selective pressure that it directly drove human innovations in camp defense, sentry rotation, and nighttime vigilance. The speculative theory proposes that the domestication of some wolves into dogs roughly 15,000 to 40,000 years ago may have been partly motivated by the dire wolf threat, befriending one wolf lineage to defend against another. The paradox is striking. The intelligence that made wolves terrifying hunters is the same trait that made the wolf-to-dog transition possible. The most dangerous predator became our closest ally. But while wolves relied on numbers, the next predator relied on a single devastating moment. Number 7. Smilodon. 3 species are recognized. Smilodon gracilis, the smallest. Smilodon fatalis, the most common. And Smilodon populator, the largest, reaching up to 400 kilograms. The weight of a modern grizzly bear. The canine teeth of S. populator measured up to 28 centimeters, 11 inches. S. fatalis carried the famous 7-inch fangs. Most people misunderstand the biomechanics. The fangs were flattened like blades. They were designed for slashing and severing blood vessels, not for holding struggling prey. The jaw opened to approximately 120 degrees, nearly twice the gape of a modern lion. That extreme opening was necessary to clear the massive fangs for the killing strike. The bite force of the canines was actually relatively weak. The killing power came from the neck muscles, driving the fangs downward in a stabbing motion. There is a fragility paradox. The canines were fragile relative to their size. A broken fang was a potential death sentence. Smilodon had to be precise with every strike. Over 166,000 Smilodon fatalis specimens have been excavated from the La Brea tar pits, the largest collection in the world. Isotope evidence indicates bison and camels were the most common prey at La Brea. Pathological analysis of dental injuries suggests injured individuals ate softer flesh, possible evidence of social group support. The most compelling case involves a Smilodon suffering from hip dysplasia since youth that survived to adulthood. That is impossible without aid from a social group. Smilodon's was built for ambush, powerful forelimbs and a stocky body designed to grapple prey rather than chase it. It likely lived in relatively closed habitats, forests, and bush, providing cover. Multiple cats may have coordinated ambush attacks. Humans walking upright presented a specific vulnerability, exposed necks with easy access to major blood vessels. The target profile matched Smilodon's method precisely. Saber-toothed cat fossils found at Schoningen with 300,000-year-old human spears confirmed direct interaction. Smilodon overlapped with early human populations in the Americas for roughly 13,000 years. The mainstream theory holds that Smilodon specialized in megafauna and rarely targeted humans. The archaeological theory argues that 13,000 years of overlap in the Americas was sufficient for significant predation pressure, and that ambush hunting in closed habitats made chance encounters lethal even if humans were not deliberately targeted. The speculative theory proposes that Smilodon's forest edge ambush strategy would have made human camps near tree lines extremely dangerous, potentially influencing early American settlement patterns toward open grasslands. Smilodon vanished between 13 and 9,000 years ago when the world it was built for disappeared. But one predator did not need a vanished world. It is still operating today using the same methods it perfected over 10 million years. Number 8. The leopard. At Swartkrans, South Africa, a juvenile Paranthropus robustus skull bears 2 distinct puncture marks. Researchers measured the spacing between those marks and matched it precisely to the mandible of an ancient African leopard. The paleoanthropologist C.K. Brain studied this evidence, and it became foundational in establishing a paradigm shift. Early hominids were prey, not just predators. The timeline is staggering. With its combination of stealth, quickness, leaping ability, and strength, the leopard has been hunting our primate lineage for as long as 10 million years. That makes this the longest continuous predator-prey relationship in human evolutionary history. The Swartkrans individual was young, possibly a child or teenager, grabbed in the dark while sleeping. Leopards can drag prey weighing as much as themselves, 60 to 90 kilograms, vertically up a tree trunk. They store it in branches for later consumption. This means trees, the one escape route from ground predators, were actually leopard pantries. Their rosette-patterned coat provides near-perfect camouflage. A leopard can sit 3 feet from you undetected. They kill with a suffocating bite to the throat or a crushing bite directly to the skull. A solitary ambush hunter making one calculated decision. In one study in Kruger National Park, 70% of baboon deaths were attributed to leopards. Leopards are the most likely culprit for accumulations of primate bones in South African cave deposits across millions of years. They hunt primarily at night when their superior vision gives them enormous advantage. Early hominids sleeping on the ground were essentially defenseless against a silent approach. The solitary nature is uniquely terrifying. Unlike pack predators, a leopard attack is a single-point failure. One moment of inattention, and someone disappears silently. Leopards are the most widespread big cat on Earth, found across Africa, the Middle East, and Asia. They still occasionally kill humans, particularly in India, where man-eating leopards have claimed dozens of victims in single campaigns. Their full primate prey list includes chimpanzees, baboons, juvenile gorillas, and monkeys. The mainstream theory considers leopards one of several predators targeting hominids, significant but not uniquely so. The archaeological theory, grounded in Brain's work, argues the 10 million year duration makes this the single longest-running predator-prey relationship in human history, and that it drove fundamental behavioral changes: group sleeping, fire maintenance, sentry behavior. The speculative theory proposes that the leopard was the decisive factor forcing our ancestors permanently out of trees. The one predator who could follow us into the canopy is the reason we abandoned it entirely. Fire was the only reliable defense. Even then, leopards would wait at the edge of firelight for stragglers, but at least a leopard hunts alone. The next predator brought jaws that could crush elephant bone, pack intelligence, and the ability to see in total darkness. Number 9. The cave hyena. This is a distinct animal from the Pachycrocuta discussed earlier. The European cave hyena was a larger subspecies of the modern spotted hyena, weighing over 100 kilograms. It was smaller than Pachycrocuta, but more intelligent, more social, and more coordinated. At Utari, an Italian cave site, archaeologists found the remains of 9 Neanderthals. All bones had been chewed, cracked open, and sucked clean of marrow. Hyena jaws generate bite forces of approximately 1100 psi. Enough to crush elephant skulls. They eat everything, including bones. Their digestive system extracts nutrients from bone material that other predators leave behind. This is why their fossilized feces, coprolites, are packed with bone fragments and are common across European archaeological sites. Pack hunting coordination involved groups of 10 to 30 individuals. The laughing call is a sophisticated social signal used for coordinating group activities. They are highly intelligent. They learn human patterns, movement schedules, and camp vulnerabilities. They could see perfectly in darkness while humans were effectively blind without fire. Their sense of smell could detect humans from miles away. Stealth against a hyena was impossible. The Utari scenario likely unfolded simply. The Neanderthals sought shelter. They found themselves trapped. Caves were not automatically safe. The broader pattern is well documented. Archaeological evidence shows alternating occupation of caves by hyenas and humans across many European sites. A deadly game of territorial rotation. Unlike other predators that killed for immediate consumption, hyenas sometimes engaged in surplus killing, attacking more individuals than they could immediately eat. As many as 100 hyena species have existed alongside primates throughout evolutionary history. In the 1950s, hyenas killed 27 people in Malawi. Modern spotted hyenas in Africa still attack and kill humans, particularly at night in rural areas. Cave hyenas went extinct in Europe approximately 12,500 years ago. The mainstream theory holds that cave hyenas were dangerous but primarily competing with humans for space and carrion, rather than actively hunting them as preferred prey. The archaeological theory points to the 9 Neanderthal remains at Utari and the alternating occupation pattern across dozens of sites as evidence of systematic, intelligent predation. Hyenas were not just scavenging, they were actively targeting human shelters as hunting grounds. The speculative theory proposes that the combination of intelligence, pack coordination, bone-crushing jaws, night vision, and long-range scent detection made cave hyenas the most complete predator early humans ever faced. The only predator that matched us in every cognitive and social dimension. The cave hyena threat was not about size or stealth or ambush, it was about being hunted by something that could think, coordinate, and adapt. But there is one more predator, and unlike every other animal discussed so far, this one is still actively hunting humans on a significant scale right now. Number 10. The tiger. In the early 1900s, a single Bengal tiger in Nepal killed 436 people, the Champawat tiger. This was in an era when humans already had firearms. Tigers are the largest living cat species. Males weigh up to 300 kilograms, 660 pounds. Solitary ambush hunters relying on dense vegetation. The kill method is a precise bite to the back of the neck, crushing vertebrae instantly. Bite force of approximately 1050 psi. Padded feet allow completely silent movement through dense jungle. A tiger can watch its prey for hours before deciding to strike. It can leap up to 10 meters horizontally and 5 meters vertically. Tigers have been present in Asia for approximately 2 million years. That overlaps with Homo erectus for most of that species' entire existence. Homo erectus populations in China learned to avoid dense forests specifically because of tiger predation pressure. Smart human groups stuck to open terrain where they could see approaching threats. Forest fires were actually beneficial to early humans, clearing dense cover and making tigers visible. Tiger eyes contain a reflective layer called the tapetum lucidum, giving them approximately 6 times better night vision than humans. In the Sundarbans, the mangrove region spanning India and Bangladesh, tigers still kill an estimated 50 to 250 people per year. These tigers do not hunt humans out of desperation. It is a normal part of their diet. Man-eating behavior can be passed from mother to cubs, creating generational patterns of human predation. Tigers that develop a preference for humans become serial predators, returning to the same area night after night. Forest rangers in India carry guns specifically for tiger encounters. Sometimes that is not enough. Most victims never see the attack coming. A single overwhelming strike from behind. The mainstream theory holds that tigers are primarily large ungulate hunters that become man-eaters only when injured, old, or deprived of normal prey. The archaeological theory argues that 2 million years of overlap with Homo erectus and documented behavioral shifts, the avoidance of forests, the preference for open terrain, demonstrate that tiger predation was a major selective force shaping human habitat choice across all of Asia. The speculative theory addresses the psychological dimension. Our fear of being watched from concealment, the unease in dense vegetation, the instinct to scan tree lines. These may be direct evolutionary programming from millions of years of coexistence with ambush cats. The tiger is still hunting humans today. This is not a historical relationship. It is an ongoing one. That completes the catalog. 10 predators attacking from 10 different vectors: aerial, aquatic, nocturnal solo, nocturnal pack, ambush megapredator, and bone-crushing scavenger. The question becomes what all of this means taken together. Lee Berger's thesis states it directly. One of the driving stresses of early hominids was being hunted by predators, a stress which may have helped our intellect evolve. C. K. Brain's paradigm shift at Swartkrantz established the framework. Early hominids were prey, not just predators. This was controversial when first proposed. Consider the multi-environment pressure. No habitat was safe. Water edges had crocodiles, trees had leopards, caves had hyenas and lions, open ground had saber-toothed cats, the sky had eagles. Multiple predators were operating simultaneously in any given ecosystem. Hominids faced compound threat environments. The man-the-hunter hypothesis dominated anthropology for decades, overshadowing what is now called the man-the-hunted framework. Predation pressure did not just kill individuals, it shaped population genetics, group size, sleep patterns, and cognitive architecture. Every human adaptation was met with predator-counter adaptation across millions of years. The fossil record is biased toward predation evidence we find the victims, not the survivors. The mainstream view holds that predation was one of many selective pressures alongside climate, diet, and social competition. Though archaeological theory argues the sheer diversity and intensity of predation evidence suggests it was the primary driver of the traits we consider most distinctly human, the speculative theory proposes that human consciousness itself, the ability to model another mind's intentions, evolved specifically to predict predator behavior. These hypotheses are difficult to test against each other, but the question is not whether we were prey. The question is what being prey made us become. The human body itself preserves the evidence. Our physiology is a fossil record of predation. The fight-or-flight response is calibrated by millions of years of ambush predation. Adrenaline systems tuned to the speed of cat attacks. Human sleep architecture operates in cycles with periodic near-waking states. These likely evolved as predator detection intervals. Our visual fields are tuned to detect movement at the edges, the approach vector of ambush predators. The startle reflex is one of the fastest neural pathways in the human body, bypassing conscious thought entirely. Human hearing is most sensitive to frequencies matching large predator vocalizations, growls, roars. We are specifically tuned to detect approaching footsteps in the frequency range of large quadrupeds. Children's fear of the dark peaks at ages when ancestral children would have been most vulnerable to nocturnal predators. Phobias cluster around ancestral threats. Darkness. Being watched. Large animals. The preference for elevated sleeping positions and shelter with walls echoes cave competition behavior. The instinct to scan tree lines and horizons appears cross-cultural, suggesting deep evolutionary programming. Modern anxiety disorders may represent miscalibrated predator detection systems firing in environments where the predators are gone. The fear is still running. The threat is not. But predation did not only take. Everything it removed from us, it also built. Fire maintenance required organized shifts. Keeping a fire burning all night demands sustained cooperative labor. Alarm call systems, the same vervet monkey evidence referenced earlier, trace a line to referential communication and eventually language. Tool development followed an anti-predator trajectory. Sticks became spears. Spears became the Shoningen weapons found alongside saber-tooth remains. The domestication of wolves was the ultimate predator-to-ally conversion. Group size increases correlate with predation pressure across primate species. Larger groups required more complex social cognition. Predicting a predator's behavior requires modeling another mind's intentions. This is the theory of mind. Cave art, the lion panels at Chauvet and the Löwenmensch figurine, represents the origin of symbolic representation through processing fear. The need for defensible shelter drove permanent settlement patterns. Projectile weapons fundamentally changed the predator-prey dynamic for the first time in millions of years. Sentry and watch behavior is the precursor to organized military defense. The landscape of fear, where prey animals avoid high predation areas, maps onto early human land management, clearing brush, building walls, modifying terrain to reduce predation risk. Cooking, enabled by fire, may have originated as a side effect of anti-predator fire maintenance. Predation pressure selected for rapid learning and cultural transmission. Groups that shared survival knowledge survived. The cognitive abilities that let us fear predators eventually let us drive them to extinction. The predators in this documentary did not just almost prevent us from existing. They are the reason we became what we are. This is not purely historical. Current predation statistics ground the entire discussion in the present. Sundarbans tigers still kill between 50 and 250 people annually. Nile crocodiles kill hundreds across Africa each year. The 2019 Ethiopia martial eagle attack on children demonstrates that aerial predation on humans is not extinct. The Malawi hyena attacks of the 1950s claimed 27 lives. Indian forest rangers carry firearms for tiger defense, and it sometimes fails. Most of the predators in this documentary are now either endangered or extinct. Cave lions vanished 13,000 years ago. Dire wolves disappeared around the same time. Smilodon followed between 13 and 9,000 years ago. Pachycrocuta has been gone for 400,000 years. Crocodylus anthropophagus is extinct. The survivors, tigers, leopards, crowned eagles, spotted hyenas, Nile crocodiles, are now largely dependent on human conservation decisions for their continued existence. The psychological disconnect is significant. Species that shaped our evolution now depend on us for survival. Habitat loss pushes remaining predators into closer contact with humans, increasing conflict. Protecting predators means accepting some level of ongoing human predation. Our fear responses, the same ones documented in our sleep cycles and startle reflexes and phobias, make rational predator conservation emotionally difficult. Ancient instincts activate in modern policy discussions. Smilodon could not adapt when megafauna disappeared. Modern predators face the same kind of rapid environmental change. The relationship between humans and predators is not over. It is transformed. GPS tracking and early warning systems are the modern equivalents of fire and spears. The central observation is straightforward. We were not born predators. We were made by them. The Taung Child, a 3-year-old killed by an eagle 2 million years ago, opened this investigation. The same predation pressures that killed that child built the species that would eventually name the fossil. Tools, fire, language, cooperation. All of it emerged from the fundamental requirement of nature: survive or be consumed. Every adaptation discussed follows basic principles: energy conservation, threat detection, cooperative defense, technological force multiplication. The domestication of wolves is the single clearest example of converting a natural threat into an advantage. Every person alive descends from individuals who outran, outfought, or outsmarted every predator covered here. We now decide which of our former predators survive. The Taung Child's skull sits in a museum, puncture marks visible, the oldest evidence that something looked at us and saw food.